Look around you. From the glowing screens in our pockets to the vast networks lighting up our cities, electricity is the invisible force that underpins almost every aspect of our modern world. It's so ubiquitous, so fundamental, that we often take it for granted. But have you ever stopped to wonder, where did it all come from? What's the incredible story behind this electrifying power? Our story begins not with wires and circuits, but with a curious observation made thousands of years ago. Around 600 BC, the ancient Greeks, including the philosopher Thales of Miletus, noticed something peculiar. When they rubbed amber, fossilized tree resin, with a piece of fur, it suddenly gained the ability to attract light objects, like feathers or bits of straw. They called this substance electron, which is where our word electricity eventually comes from. They didn't understand why it happened, but they were witnessing the very first recorded interactions with static electricity. A small spark of curiosity, literally. For centuries, this phenomenon remained largely a novelty. It wasn't until the 17th century that serious scientific inquiry began. An English physician named William Gilbert coined the term electricus to describe substances that behaved like amber. More importantly, he differentiated between magnetic attraction and this new electric attraction, laying crucial groundwork. But the true nature of these forces remained a mystery. Fast forward to the 18th century, and the brilliant mind of Benjamin Franklin entered the scene. Franklin, famous for his kites and keys, proposed the concept of positive and negative charges, and that electricity was a fluid that could be transferred. His daring and famously dangerous kite experiment in 1752 helped to demonstrate that lightning itself was an electrical phenomenon. This wasn't just a parlor trick. It was a profound realization that connected the sparks generated by rubbing amber to the immense power of a thunderstorm. While static electricity was fascinating, it wasn't practical. The real breakthrough for continuous, usable electricity came with Alessandro Volta at the turn of the 19th century. In 1800, Volta invented the Voltaic Pile, the very first true battery. This revolutionary device stacked discs of copper and zinc, separated by brine-soaked cardboard, to produce a steady flow of electric current. For the first time, scientists had a reliable source of electricity to experiment with. This was a game changer. The Voltaic Pile immediately opened doors to new discoveries. Humphrey Davy used it to create the world's first electric arc lamp, producing a blinding light that was far brighter than anything previously known. The potential of electricity was beginning to shine through, but electricity's relationship with another fundamental force, magnetism, was yet to be fully understood. In 1820, Hans Christian Ørsted made an accidental, yet profound, discovery. He noticed that a compass needle deflected whenever an electric current flowed through a nearby wire. This showed that electricity could produce magnetism, electromagnetism. André-Marie Ampère quickly expanded on this, formulating the mathematical relationship between electric current and magnetic fields. This was a monumental leap, linking two seemingly separate forces. If electricity could create magnetism, could magnetism create electricity? This was the question that obsessed Michael Faraday, a brilliant self-taught scientist. In 1831, Faraday achieved another monumental breakthrough, electromagnetic induction. He showed that moving a magnet near a coil of wire, or moving the wire near a magnet, could induce an electric current. This principle is the bedrock of almost all modern electrical generation. Think about it. Every time you spin a coil of wire near a magnet or a magnet near a coil, you're generating electricity. This discovery paved the way for the electric generator. Conversely, if a current could create magnetism and magnetism could create movement, then electricity could create motion. Faraday also developed early prototypes of electric motors, demonstrating how electromagnetic forces could be harnessed to do work. The separate strands of electricity, magnetism, and light were finally woven together by the theoretical genius of James Clerk Maxwell in the 1860s. His groundbreaking equations unified these forces, proving that light itself was an electromagnetic wave. This was one of the greatest achievements in the history of science. With the scientific understanding in place, the stage was set for the practical application of electricity to transform daily life. The late 19th century saw an explosion of innovation, spearheaded by figures like Thomas Edison. Edison's work on a practical, long-lasting incandescent light bulb in 1879 was a turning point. But a light bulb needs power. Edison built the world's first central power station, Pearl Street Station in New York City, in 1882. This landmark event marked the beginning of public electricity supply, bringing light and power to homes and businesses. However, Edison's direct current DC system had limitations. DC couldn't easily be transmitted over long distances without significant power loss. This is where Nikola Tesla, often championed by George Westinghouse, entered the war of the currents. Tesla championed alternating current, AC, which could be stepped up to high voltages for efficient long-distance transmission, and then stepped down for safe use in homes. AC ultimately won, becoming the dominant system for power distribution worldwide. The potential of AC was fully realized with projects like the Niagara Falls hydroelectric plant, which began generating AC power in 1895, sending it to Buffalo, New York, over 20 miles away. This was a triumph of engineering and a testament to the power of AC. From then on, the electrification of the world accelerated rapidly. Homes were wired, factories hummed with electric motors, and new appliances made life easier. Electricity began its irreversible transformation of society. Today, our understanding of electricity continues to evolve. From the intricate dance of electrons and semiconductors that power our computers, to the global smart grids managing energy flow, the principles discovered centuries ago are still at play, but on an unimaginable scale. As we move towards a future of renewable energy, electric vehicles, and increasingly interconnected smart technologies, the story of electricity continues to be written. It's a testament to human curiosity, ingenuity, and the relentless pursuit of understanding the fundamental forces that govern our universe. So the next time you flip a switch, charge your phone, or simply marvel at the glow of a city at night, remember the incredible journey of discovery, from a curious piece of amber to the pulsating heart of our modern world. The story of electricity is, truly, one of the most electrifying tales of all.